Hello and welcome to my 8th grade study science podcast. Today we are going to be reviewing the topic of plate tectonics for my study guide. First we're going to start off with Earth's layers. How can Earth be divided into layers? Well, there's physical layers, the crust, mantle, and the core, and there's chemical layers. Chemical layers are as follows. The lithosphere, which is the crust and the uppermost part of the mantle, the asthenosphere, which is the rest of the mantle, the mesosphere, which is the very bottom of the mantle, the outer core, which is the outside of the core, it is mostly liquid, and the inner core, which is, as you guessed it, the inner of the core. It is basically a giant ball of solid iron. The lithosphere is very rigid and it does break, whereas the asthenosphere, the layer below it, is a soft and not rigid layer that flows very easily. The inner core is also a very solid layer. It is rigid. It does not really break because it's a spherical object. Whereas the outer core, just like the asthenosphere, is a soluble and flowable, even though flowable is not a word, layer. Moving on to continental drift. The theory of continental drift was a theory by Alfred Wegener, and he thought that the South American continent and the continent of Africa seemed to fit together. Now, he ended up being able to prove this with fossils and other things, and he proved that they were once together, but he couldn't explain the drifting that was happening. So we did a lab in class where we tried to demonstrate how the layers of the Earth broke apart and spreaded, or C4 spreaded. Now, the exact way that this happened was the convection, which is a force happening inside the Earth, caused the lithosphere to break in half and move apart. Now, there's a lot more complicated terminology to use, and there's a lot more steps, but to make it simple, basically, the center of the core was heating up the lithosphere very rapidly, and it caused a cycle where at some points the lava would be less dense and at some points it would be dense, and it started a circular flow, also known as convection. This current, also known as convection, is what broke apart the continents and spreaded them out. Now, at first, the scientific community completely rejected Alfred Wegener's theory. This was due to the fact that he couldn't explain the seafloor spreading at the time because, well, they couldn't go down into the seafloor. Now, to move on to the mechanism movement. Why do the continents move? Well, they move because of the action/force of convection. How does the age and magnetism of the seafloor support the movement of the lithosphere? So, the seafloor that is closest to you when you are going for a swim in the ocean, that is the oldest and coldest seafloor, and that is north magnetism. And then the seafloor that's a little bit farther out is a little bit hotter and a little bit younger, but it's south magnetism. So kind of makes a layer that locks together that can be snapped in the middle, like magnets. And the seafloor that is obviously closest to the center of the ocean, aka the Mid-Atlantic Oceanic Ridge, is the youngest and the hottest because that just came out. How does geologic evidence provide clues to Earth's past, present, and future? So if I'm in Europe and I'm seeing mountains that are of similar rock structure to the ones in, let's say, North Carolina, even though North Carolina doesn't have that many mountains, that may suggest that the rock types were once connected and part of a single mountain range, and we did a activity which was, I forget. Oh, when we put a sheet of paper with different squares in between tables, and as we pulled them out, we saw that a mountain range that used to be there was torn apart, really. Thank you for coming with me and studying for this Earth's layers. It was a very good unit, Earth's interior. I would definitely recommend it to other students. Thanks for studying. See ya.